Welcome to the DIY Honda Garage channel. The error code P16F5 pertains to the starter cut relay 1 control circuit, indicating a high voltage issue. This code is crucial for understanding problems related to the starter cut relay, which plays a vital role in regulating power to the starter motor, ensuring the engine can crank when required. The PCM, or Powertrain Control Module, monitors the return signal from the starter cut relay to ensure it remains within normal parameters when the signal is deemed high while the starter is intended to be engaged. The PCM recognizes this anomaly and triggers the DTC. Understanding this code and its implications is important for diagnosing and repairing related vehicle starting issues. For the Honda CR-V 2023 and beyond, this could indicate wiring issues, relay failure, or PCM faults that require thorough inspection and testing to resolve. The DTC P16F5 indicates that the starter cut relay 1 circuit has recorded an abnormally high voltage in its control circuit. The primary components involved in this situation include the starter cut relay 1, which is responsible for allowing or inhibiting power to the starter motor, and the PCM, which oversees this relay's function by interpreting its return signals. The starter cut relay is typically positioned in the relay circuit board, and it connects the power from the battery to the starter motor when the ignition is engaged. If the relay or associated wiring malfunctions, it may send a high voltage signal back to the PCM, leading to this error. This kind of malfunction not only affects starting the vehicle, but also poses risks of further electrical system damage if not resolved promptly. There are several potential causes for the DTC P16F5 regarding the starter cut relay circuit. One significant suspect is shorted wiring, which may create an unintended pathway for voltage, leading to the high signal. Additionally, a faulty starter cut relay could fail to operate correctly, causing communication issues with the PCM. The PCM itself may also develop faults, preventing it from accurately monitoring the starter cut relay's function and signals. Each of these conditions can disrupt the normal interplay of the starting system, making it crucial to diagnose them accurately. Addressing the root cause not only resolves this DTC, but also safeguards the vehicle's overall electrical integrity. When the DTC P16F5 is triggered, the most common symptom experienced by drivers is an inability to start the engine. This is due to the starter cut relay not functioning properly, resulting in a lack of power delivery to the starter motor. Additionally, drivers may notice high voltage warning signals on the dashboard or through diagnostic tools, alerting them to potential electrical issues within the vehicle. Furthermore, if the PCM is actively monitoring for errors, this DTC will be logged, and additional PCM error codes may also be present, indicating related problems. Effective troubleshooting should take these symptoms into account, helping to guide technicians toward an efficient diagnosis and repair. The first troubleshooting step for DTC P16F5 involves starting the engine and confirming its operational status. This step is essential as it helps ascertain whether the high voltage signal is a transient fault or a persistent issue. If the engine starts without issues, further diagnostic approaches are necessary to ensure that the starter cut relay and related circuitry are functioning correctly. Conversely, if the engine fails to start, the situation indicates that the starter cut relay might be preventing power from reaching the starter motor. Such a scenario necessitates a closer examination of the starter cut relay and related components. Documentation of the PCM's response during this process provides invaluable data for subsequent steps in the troubleshooting procedure. In this second step, the technician needs to inspect the relay circuit board, specifically focusing on the starter cut relay section. This includes checking for visible signs of wear, corrosion, or any disconnections that may indicate a problem. Ensuring solid connections within the circuit board is vital because any interference can lead to a false high-voltage signal transmission to the PCM. Additionally, testing the typical operating conditions of the circuit is crucial to verify its integrity. If the relay circuit board shows normal function, further investigation into the other components becomes necessary. This inspection helps isolate whether the issue is localized or part of a wider systemic failure. The third troubleshooting step involves executing an external circuit test to identify any shorted wires connected to the starter cut relay. This step is critical for finding faults in the wiring harness that could lead to high voltage signals being relayed incorrectly to the PCM. Technicians will utilize specialized tools to check continuity and identify any breaks in the wire or unintended paths to power that could cause erroneous signals. In some instances, shorts can develop due to wear, exposure to heat, or physical damage to the wiring, which can compromise electrical safety and vehicle functionality. Detecting and repairing such shorts is essential not only for resolving this error code, but also for preventing future electrical problems in the CRV. The final step of the troubleshooting process consists of conducting a PCM inspection to determine if the module itself is functioning correctly. A faulty PCM can misinterpret signals from the starter cut relay, underscoring the need for rigorous testing post-initial inspections. Technicians will verify that the PCM operates within designated parameters and has not sustained damage or corruption. Diagnostic tools may be used to read related error codes to cross-reference with the findings. If the PCM confirms normal operation, the likelihood of it being the source of the issue decreases. Conversely, if problems are noted within the PCM, replacing or reprogramming the module may be necessary for a comprehensive fix. Following repairs or replacements made in relation to DTC P16F5, it is imperative to conduct a final repair verification procedure. This involves clearing any stored error codes from the PCM to reset its memory and eliminate past faults. After this, the technician should start the vehicle several times and monitor it under different conditions to ensure that the warning does not reappear and the engine starts efficiently. Ultimately, confirming the functionality of all related systems guarantees that the repair is effective. If the DTC does return, it indicates that further investigation is required, as the initial repairs may not have resolved the underlying issue. This process is critical for maintaining vehicle performance and reliability. Preventive maintenance is essential in avoiding future occurrences of DTC P16F5 and similar issues surrounding the starter cut relay and associated circuits. Regular inspection of wiring harnesses for wear, corrosion, or physical damage will help to catch problems before they lead to failure. Additionally, monitoring the performance of the starter cut relay on a routine basis can alert owners to potential issues before they become serious. Preventive measures not only ensure that the vehicle starts reliably, but also safeguard the longevity of the electrical system as a whole. Incorporating this maintenance into regular service intervals will significantly reduce the chances of facing similar DTCs in the future, promoting a more dependable driving experience. In conclusion, understanding DTC P16F5 is vital for troubleshooting problems related to the starter cut relay circuit. Recognizing that the PCM plays a central role in monitoring relay status and signaling faults is essential for effective diagnostics. Technicians should thoroughly check both the relay and the associated wiring to identify possible shorts or faults that could lead to high voltage readings. Preventive maintenance, such as regular inspections of these components, can help avoid future occurrences, saving time and costs associated with unexpected failures. Following a systematic troubleshooting guide not only resolves the current issue, but also enhances overall vehicle reliability. Investing attention to these details contributes to a more dependable driving experience in the Honda CR-V. Please like and subscribe to the channel. See you next time.